So my talk is seeing the forest for the trees. And when I was debating what to do, usually when I talk about monitoring at conferences, the audience is a broad spectrum. A lot of people don't really know as much. They're much less sophisticated than, say, even us in this room. So I give like higher level talks. And with Monorama, I was trying to decide what to talk about. And I thought one thing's in our community, DevOps, we're really good at like back-end collecting data and organizing it and doing queries, but for the most part, we're all really bad about visualization, right? Like that's almost something where after we've built our collectors and our storage, we say, oh, we need something to do with this, and we slap some viz thing on it. So I want to kind of talk through some ideas around that. So that's just the intro slide. That's me. I'm going to start motivation. Monitorama, what even is monitoring? So at the highest level, I call that just distilling the raw metrics or data into actionable insights, right? And doing that with as small a gap between that and as little cognitive overhead on the user as possible. Targeted more specifically to like DevOps operations guys, I'll say that monitoring is unit testing for operations. If you need some way to explain it to someone who is not responsible for 24/7 infrastructure, who does not get paged in the middle of the night, you need to talk to a developer, you can just say, hey, it's our unit testing. It alerts us to regressions when we've changed things in production. It allows us to test hypotheses over whether or not the code we have put into production improves performance in the way we wanted it to. And then I've been monitoring into kind of three broad areas. So one is the actual data collection. I think we're really good at this to a certain extent of like putting it. There are lots of existing tools for instrumentation on servers in your application. Whether or not everyone is deploying them to the extent that they should, I give talks to that extent where most people aren't. But the tools are there. And that's what generates all the raw metrics. Once you have all of your raw metrics, though, there's kind of two broad categories. There's automated analysis, like threshold-based alerts. There's a lot of actually interesting things going on in this field. So when we think about the entire set of all the data streams we generate, it's too much for human consumption. So we need something that can mine those and find things and alert us to interesting situations. And that's a really, I think, interesting area of research right now. And companies like us and other places are doing some neat things there. But today I want to talk about the third piece, which is information visualization. And that's because in any situation, from whether it's your business level to a particular service level down to just a resource that comprises a service, you have a set of key performance indicators or KPIs. Like that's not just a business intelligence term. That's something that applies to anything of importance that you're monitoring. There's one or two high-level metrics about that that tell you pretty much binary whether or not things are healthy. And pure visualization is really good for those because no machine or algorithm is ever going to be as sophisticated as the human brain is just an amazing capacity for pattern recognition and detecting subtle things, right? I mean, alerts and thresholds are good, but what I find more interesting is when you look at a dashboard and everything's healthy, everything's fine, but you look up and you say, oh, that's interesting, that pattern. Like that's within the range, but it's changing. In our KPIs, using dashboards, it's very easy to kind of see those things. So I'm going to focus on dashboards specifically for visualization, because I think for monitoring SaaS infrastructures, those are of particular use. And specifically dashboards, if you want to define them, they're a visual display, and it's a summary of actionable information. That means it's not going to tell you everything you need to completely do your job. It's going to give you a summary of all the high-level things you need to know. And it's going to be consumable at a glance, right? Our brains will be able to look at it, glance, recognize everything's fine or something's wrong. If something's wrong, we're going to drill into more specific query interfaces or correlation machines to look at the actual specific problems. And dashboards, I think, of kind of like three broad areas. The first one is definitely aberration detection. That's like a common one. That's what everybody thinks of. I glance at the dashboard, I see something different. And the quote I generally like to tell people I'm selling them on that is that no aberration detection mechanism is more sophisticated than your marketing guy, which is in my case Nick, looking at one of our dashboards with a cup of coffee, right? And you'll be amazed, especially if you sit with one of those boards to your back, when someone will come by your desk and say, "What's that?" And you'll look back and you say, "Don't worry, go away. Like, I'll fix that." So that's the obvious one. But there's some, I think, some more subtle things. So they give us a shared understanding, right? When we have a common dashboard that everyone in the organization can look at, we're all working from the same set of facts. And that's not just important when we're trying to kind of coordinate during an incident. It's really just important about basic decision making. Like, I think a lot of strife happens in organizations when we don't have data about something. So what we do have is opinions. We get emotionally attached to those, and we start fighting. And there's a quote I found this I really liked. So it says, "If we have data, let's look at data, and if all we have are opinions, let's go with mine." And that was the Netscape CEO, I think Jim Barksdale. So apparently at least one of his opinions was not so amazing, and there was lacking data. So having dashboards, you don't have to fight over certain things. You can look and you can see the data, and you have a good base to start. The third is actually they give you institutional knowledge, right? And going back, just like as you should have some concept of a KPI for your business, for your individual services, even for your resources. Like, I think of our dashboards in a hierarchy, right? So I have a business level dashboard that tells me the 5 or 6 things driving my business, how are they doing today. For any given service, I have a dashboard that I can load for that service that will tell me the critical things I need to know there. And then for the resources like a server or a database that make up that service, I have a dashboard that gives me the high level information. And for firefighting scenarios, what that does is your domain experts, like the guy who owns that service, wrote that service, can build that dashboard. And then in the middle of the night when he's on vacation or something and the alarms go off, whoever gets the page can load the dashboard for that service. And if there's anything wrong there, at least he's cut the gap on time to detect something. So that's, I think, at a high level, what I find really interesting about dashboards. So now that if we've established that they're really important, if you believe that, I want to talk about actually visualizing them. Because what we tend to do, because it's easy, we throw up an array of line graphs, and even like our dashboards at Librado are currently that, because that's kind of the first order approximation, right? A line graph is the most powerful, common kind of visualization you can have. But if we look at some actual principles of perception, we can start to come and understand why there's some of these other visualization types that make a lot of sense. So human memory, let's start with that. Human memory, there's 3 kinds. And it's actually interesting when I was reading about this, because our memory works actually a lot like the memory hierarchy in a computer. We have the iconic memory, which is when light actually hits your eyes and the brain turns that into an image. It goes into this iconic memory, where it only sits temporarily before it gets moved into short-term memory, which you can kind of think of as RAM. And in the RAM, you have capacity for 3 to 9 discrete chunks of information at any one point in time. And then to bring something else in, once you've got your 3 to 9 chunks in there, to bring something else in, it's kind of just like RAM. You have to move something else out to swap, I guess if you want to think of it, your long-term memory. Or you just lose it. If it's something that just flashes briefly, you may forget it altogether. So you either drop it on the floor, it goes in long-term memory. So a couple implications of that. One is that when you're looking at a dashboard, if you just look at, say, 6 numbers, you have to remember 6 different things in your short-term memory. If you look at a graph with 6 lines, that sets as a single chunk, right? So that's part of the reason graphs are powerful, is because they limit the amount of short-term memory we need to use to understand what's going on the dashboard. With iconic memory, there's this thing called preattentive processing, which means when an image hits our iconic memory, on its way into short-term memory, we actually do a bunch of processing in our subconscious, right? And there's 2 kinds of things we can do. It's called categorical or quantitative. So categorical lets us distinguish 2 things, but doesn't really tell us about how they relate to each other in a quantitative sense. And quantitative is what tells us, like, hey, this thing is bigger than that thing. So some examples, this is called an enclosure. So that tells us that these things are related. Another categorical preattentive is it's called added mark. So we we notice that thing because we've added a mark to it. An in practice example of that is, if you do this like with vibrato or graphite where you draw an annotation, like we immediately know that this line is connected to whatever happened to the graph at that point. Color. So color is interesting. So if I were to ask you to tell me how many times the number 5 appears on this, it's going to take you some time to scan that. If I ask you now, you can tell me, oh, it's 4. There are 4 5s there, right? And that's because we've changed the color hue. And that's another categorization. What's interesting is we can do that with intensity as well. Like this is just a grayscale. And we can also, what I tried to show here is you can use intensity for a small amount of quantitative information, which is roughly 5 levels of quantitative information. And I've just got 3 here, the original ones in the bold. On that same line width, we can use line width for a limited amount. We can highlight 2 or 3 different widths. Moving into another limited quantity, we can use 2D area. So we can denote that this thing's bigger than the other. This one's tricky. You can get yourself into trouble, though. So you can use to just say this one thing's bigger than another. But if we start to get into relative size, so everyone just pick a number in your head. There's 2 circles here, and try to figure out how many times larger the big circle is than the small one, right? So everybody's got a number. The answer is 25 times. So I'm going to guess most people were less than 25, right? Yes, yeah. So the human brain, we tend to underestimate 2D area, like significantly in some cases. Now, 2D location, we're really, really good at. So this is an awesome quantitative preconception. Yeah, preattentive, sorry. So 2D area is really good for quantitative information. And line length is the other thing that's really good for quantitative information. And that's why graphs, another reason graphs are so powerful, because we can, things like bar charts, we have line length and a 2D placement, and line graphs, we have the 2D placement of the lines to access. So using that knowledge, you'll see now we're going to go into some higher level stuff, how that actually builds in. So the first thing, talk about, because now that we know we're doing this like pre-attentive, pre-conscious processing, there's this thing called a data-ink ratio that Edward Tufte, how many people heard of Edward Tufte? Probably a lot, right? Yeah, so he's like the father of quantitative visualization. He's actually doing, random note, he has a San Francisco workshop coming up soon, I think, either San Francisco or Portland. But he does workshops, you can go see him. But he defined this thing called data-ink ratio, which is basically when you're doing a visualization, you should consider the ratio of the number, the amount of ink, or we'll say pixels, the number of pixels that are actually used to communicate quantitative data or grouping versus the number of pixels that are what he calls chart junk, which aren't doing anything. And an example of that, so here's an original chart showing a bar chart. But as you step through, we can start by removing the grid lines and our perception of line length. We didn't really need those. We can remove the background color. That wasn't doing too much for us. And then finally, we can now use the added mark principle to say, well, we'll remove the outer box. We'll put the added marks. So now we can see in relation to each other what months are bigger. And we can also see what months belong to the groups that cross 5, 10, and 15%. And we got there from the previous one. This is much easier to read, less data ink. And I like to think, the principle I like to think about this is kind of what this famous Einstein quote, because I think you can definitely take this to an extreme. And it's kind of an art to a certain extent, how far you go. That was an example by itself. If you were grouping those, you may have needed a little more differentiation between the different ones. So just, you should remove as much non-data ink as you can, but no more. Semi-related tangent I thought was funny as I was looking up this quote, because this is one of my kind of favorite quotes, even relating just to software development, right? Like we should make our services as simple as possible, no simpler. That's not actually what Einstein said. This is a paraphrasing. What he actually said was, it can scarcely be denied that the supreme goal of all theory is to make irreducible basic elements as simple and as possible without having to surrender the adequate representation of a single datum of experience. So in kind of a meta sense, he failed to take his advice when making this, this quote. So another principle this concept of small multiples. So line graphs are great. We can kind of conceive up to, like, say, 5 lines before they start to turn into a mess. When you get much more than 5 lines, we devolve into this, I can see outliers, right? I'll see most of the lines are grouped together. Like if you've got like 50 servers in your graphing load, what you'll see is a big chunk of them in the same area and then the outliers. What this small multiple says is perhaps a better way to do that is to come up with a smaller representation and then do each one individually. And a cool example I found, this is the trilogy meter. So what this guy did was he took all these movies that have trilogies and he made a bar graph of how much he enjoyed them. And so because we're doing pattern recognition now, right? So our short-term memory is not overloaded as much, right? So we can see that in a lot of cases, the second movie is the best one. And in pretty much all cases, the third movie is terrible, right? And then there's a few where, like Lord of the Rings, where he just liked them all the same. But you'll see this principle repeated in a couple places. So building on that, let's talk about some actual display media that you can use besides, say, line graphs. So bar charts are really important. And one of the reasons they're important is because people have a tendency to do stuff like this. This is a pie chart. And you see these everywhere. And the problem with the pie chart is we know now that 2D area, we're really bad at estimating 2D area. This was actually taken from a real publication. It's the home attendance of every team in the major leagues in 2011. And you can't really tell much of it other than, yeah, I don't even know what you can. So the same data in a bar chart, right? You can order it because there's no, this isn't like there's no like ordering relation to these other than their actual quantities. So you can sort the bar chart by length and we can just immediately see things like, surprisingly, Philadelphia had the most attendance. I would never have guessed that in a million years if you're much of a baseball fan. Yankees, that makes a lot of sense. San Francisco, we're right up there. And then our buddies in Oakland down at the bottom are having a little tough. So for everybody from the East Bay, that's probably why the chickens are so cheap. So I think generally speaking, you always want to order your bar charts in terms of magnitude if there's not a relation in if the order doesn't matter other than the quantity. The alternative is obviously everyone, histograms are an example of where you want to order based on something else. And this is, I think this is a graph of ping latency from like AWS US East to Google.com. And this is a classic latency distribution we see where averages are a big problem because we've got a cluster down that's really good, and then there's a big cluster or a smaller cluster that's really bad. And this next one, just to drive home, it's pretty amazing what you can find on the internet. So this is another pie chart I found, which, yeah, not only do we have problems with 2D area, but there's 3D stuff. Generally speaking, I didn't want to go into this too much. We can perceive 3D area, but rendered on a 2-dimensional surface, it's actually very hard to communicate that properly. So you should almost always stay away from 3D stuff. So another interesting thing, bullet graphs. So Stephen Few came up with this, and he wrote the book, which is awesome, about all this stuff called information dashboard design. But bullet graphs are media he came up with to replace this problem. So speedometers, right? So we've all, I think, all seen dashboards with stuff like this. So does anyone know why speedometer's round and has a needle? Because when it was invented over 100 years ago, there's an actual gear that turns something, which then moves a magnet, which then pulls through torque, the needle to the right spot. And none of our computers that have dashboard have any of those things in them. And you get into more problems like this. At least this one, a lot of times the needle obscures the number, but there's no idea. So this says 45. Is that good? Is that bad? I don't know. It's round, so there's wasted, the white space where the square is drawn is all wasted if I stack a bunch of these. So the bullet graph is an attempt to cover the same kind of, actually more information in a space, and a much denser space. So we're using a couple principles here. We're using our shades of intensity. So if you can kind of see, it's hard maybe to see, but there's a grayscale on the back of the bar. So that tells us, good, better, best, amazing. The black inner bar tells us what our current value actually is on that scale. And the added mark is going to tell us whether or not we've hit a target. And in terms, what I kind of am thinking of experimenting using this is for that service level KPI, where you can use that target as either like our last period, so you can see how you're doing period over period, or maybe as this is the point after which things start to break. And using small multiples, you can kind of scan this really easily, and because where it crosses the target, it makes a cross. We can see really quickly that, okay, revenue, customer satisfaction are awesome. We're not doing so good on new customers. Average order size is not good. And I guess most importantly, profit is not where we need it to be. Another interesting horizon charts. So this company called Panopticon came up with, but then the team at Stanford that Mike Bostock came out of, Jeffrey Heer, I think they work with Ben Schneiderman, popularized this. So the idea is, given a time series, so that the original time series is at the top, given a time series that and including one that fluctuates around the 0 axis, how can you compress that such that we can use small multiples to show a lot of individual ones? And so what they do is they first they color negative values one color, positive values another. They then take the absolute but keep the color mappings, and then they start to literally fold the series on itself. So when we go from here to here, you can see the upper section is folded down. So we can see from the color intensity, remember intensity matters, that this is much higher than, well, even here. And if you look at this at a large scale, this is stocks, like 50 stocks. I forget what time frame, but we can kind of instantly see like France Telecom is not doing so well.
It's about a year.
Yeah, Ross Discount Stores is doing pretty good. And in an actual, I don't know how to do JavaScript in Keynote, I don't think you can. Cubism.js, put out by Square, Mike Bostock did there, is a JavaScript library to do this. It will actually snap a vertical cursor across those and kind of show the values at each point. So if you see an area where there's like a cluster of interesting stuff, you can just snap there and see what's going on. So then, in closing, so that's a lot of like principles, practices, even tools you can use. A very important thing with your dashboards is just like alerts is to constantly be iterating and refining. When you build that service level dashboard and then you have an outage and it turns out it didn't tell you anything or anything what you needed to know, figure out what was different, update it, change it, right? Because you want, these things are, our services and our code changes and your dashboards need to be updated with them, just like your alerts. I say the same thing about alerts. Always be using the signal and noise ratio too. If there's an instrument on your dashboard that turns out you never use or isn't important, get rid of it, right? So then, I guess in closing sources, I talked about Tuft. This is his kind of seminal book on that talks about Data Inc. and all those things. Stephen Few, his book, which I think if nothing else, just read this. This will put you way ahead of where you need to be. It's out of print right now because he just got in a very public spat with O'Reilly. So he took rights to the book back, but he's self-publishing a second edition this July. It's supposed to come out. And he lives in Oakland. He's publishing out of there. So then just in closing, I would say, because new stuff, no one should feel bad about what you've done with visualization up to this point for two reasons. One, I like this quote. Errors using inadequate data are much less than those using no data at all, like our Netscape CEO's decisions probably were. And the last bit is, I just came across this while I was building this deck. When I was writing those circles. So I went into Keynote and I hit the charts button. And of course, they have a little pie chart icon, but then there's a 3D pie chart icon. So I was like, oh, I'll just click that and see what comes up. And this is the default that comes up at a Keynote. And I imagine Apple has a lot of like very highly paid data viz people. So it happens. We just all need to work on making things better and learning more about this and improving our tools. So, and that's it. If there's any questions, you could save the brutal feedback maybe for after, and if you're going to call me names or anything. But yeah.
Flip back to that slide one.
Which one?
Just the last one. I was trying to decide whether the circle was round.
Yeah, well, it's 3D, right? It's like someone said this pie chart, and I'm going to use Italian marble to differentiate the colors because that's not distracting. It needs to be 3D too. I'm not At least the 3D pie chart earlier, the slices had some stacking. This is literally just someone was like, no, tilt it, it'll be awesome, right?
How important is interactive dashboard?
Oh, yeah, I mean, I think it's important in two very important ways. One way is, like I said at the beginning, the dashboards are just, or not just, but they're a high-level summary. You see at a glance something's wrong. So from that point, if something is wrong, you need to figure what's out, you need to drill down into the place. So I mean, like on our dashboards, for instance, any one of your instruments, you can click on it and it takes you to like a much more involved correlation interface. And I would recommend any tools that do that kind of thing give you drill down ability. The other thing you can do, and again, I'm not trying to toot my own horn, but what we do I think is interesting is let you set up a dashboard, say for a given database, but then you can toggle that one board from database to database. So if you have a service made up of n servers and you're trying to flip through them real quickly, I think that level of interactivity is important too.
And the other thing would be is if your dashboard, if you know the patterns that are problematic, should the dashboard recommend a standard course? Not necessarily say that this is how to do it.
I mean, one thing it should do, and I didn't, because of the pre-attentive attributes, there's actually like 17 of them. I cherry picked like 4 or 5 for brevity. But there are certain things like actual animation or flickering you can use. So for your thresholds, your dashboards can do things like if they detect a certain things out of threshold, they could actually make that much more visible even than just the pattern. Like they could make it start blinking or...
I'm going beyond that. I'm saying that it could have like a pop-up of this is the action that you should take.
Oh, you mean like tie it into like a run book or something like that? Yeah, I mean...
for example, if you're working at Kaiser, if you have a clash of 2 different drugs, you would give it up and say, these can cause a problem. You can override it, but we know that.
Right. No, it's a really interesting idea. I mean, I think tying it into like hey, this is the procedure. When this instrument starts blinking, you click through and you see this is the procedure. These are the things to start trying. Because really, when you hit an incident, you end up with some kind of graph that you're like, okay, this graph is a problem, and you're all working until that graph corrects itself, right? So yeah, I think that's actually a pretty interesting idea.
Dog has that notation, or that notion too, is when you fix something in Datadog, you go down it, you can actually put, what did I do to fix this last time? Immediately
record
when
it.
that threshold again, it automatically puts up what did Joe Schmo do last time
Right.
to fix this problem. So definitely tying it into a visual app.
And it should probably also put in, this is what I did to make it worse.
Yeah, or that.
Yeah, I mean, I think what's important with those things is always, I guess if you're writing those, you want to phrase it as in like, try this, and then this is the success or fail on trying that, not like just blindly plunder ahead and do these things.
Yeah, because you can have an alert on your database because the disk failed. The next time your database failed, you don't want to be swapping disks necessarily.
I'm wondering if I'm being overly pedantic here, but it seems like most of your presentation is more about graph design than dashboard design. And I wonder if that distinction is a useful one.
Yeah, I mean, there is a higher level then of, because with dashboards, right, there's things like, we tend to, in Western societies, we look to the upper left, right? So one of the things you'll see, a lot of commercial dashboards where they'll have their logo up there, and that's like the worst place to put it because, well, depending on who you're talking to. For them, for the marketers, but for the people who have to use it in anger. So yeah, so in terms of building a dashboard, I mean, that's a good point. I mean, if I have time, part of it is a time constraint. Like I'm trying to start from like first principles and get as far as I can. But yeah, there's definitely a whole section on actually designing, taking these things and putting them together and place.
Let's take the brutal criticisms for after session.
Okay.
Sorry, I wasn't trying to criticize. I was just
No,
trying
no.
to see if I was looking at it the right way.
No, you are looking at the right way. That would be the logical next step of if this was another 10 or 20 minutes. Absolutely. Dave.
So where do you draw the line between like what you're monitoring and what you're putting up on a dashboard, right? Because we don't want to sit around all day staring at our screens like that. It's totally stinks.
Yeah, well, that's why I think you need to, at whatever level, because like I said, I like to think in terms of like my dashboard hierarchy, where the ones that are actually up on the wall are the top level business ones. I mean, I think you kind of have to say, I'm collecting 100,000 metrics. These 6 are the ones that determine whether or not my business is successful today, and kind of build down. And at each level, it's like, for a given service, these are the 3 or 4 things that tell me the service is up and healthy. So you can kind of build a drill down like that. But yeah, you can't have like every single metric goes onto a dashboard. And I mean, these are definitely supposed to be summary of the high points, right? That you can look at. The at a glance thing is important too. If you can't look at a glance and tell whether or not things are good or bad, then it needs work.
If I may add, things that are likely to change should go on dashboards, and things that are aggregate, like all-time totals, drive me nuts on dashboards, like all-time installs, that are,
Yeah, vanity metrics, right?
But, I mean,
That would drive you nuts, but it wouldn't drive a marketing person nuts or a sales person nuts.
well, it depends on what the goal of the dashboard is, I guess.
Yeah.
So maybe that's actually the really important point, right? I mean, the dashboard is meant for a certain audience, and different audiences.
Absolutely, yeah.
want different things, right? I mean, our operational dashboards are very, very different from the kind of dashboards we have, for example, when we launch a new country, and people are really, really interested in that monopoly.
Actually, that's a good question. To me, it feels like that's the case for Splunk, right? You look at Splunk, you can put the data in any presentation you want. You click on it, you get the raw data. Whether or not you care about it is up to you or clicking on it, right? So you can put it in a data dashboard. I think that's sort of the broader thing too. Is like once you have that data in their system, you should be able to drill down and see it in whatever form we want. From a, if the CFO asks why does it look like this, you should be able to explain it within probably 2 clicks or 5 minutes, right?
Yeah. Yeah, I mean, the business level dashboard that your CEO cares about versus the top level dashboard that your VP operations cares about are 2 totally different things. But it is really cool that you can share that, right? Like if the CEO actually has, hey, this is the business level dashboard that everyone in the org can see, I think that lends to a much greater deal of like trust in your org. And again, what's that? Transparency, and not arguing over stuff and wasting like political capital and energy over things that you don't need to argue about if the data's there for everybody.